Okay, here's another example that's quite similar to the last one, but instead of using factors, we're going to use the technique multiplying by the conjugate to simplify the square root. So let's begin. The question is, the limit is x. The limits are a of, as x approaches 0 of the square root of x plus 1 minus 1 all over x. So let's again begin by writing out the question. The limit as x approaches 0, square root of x plus 1 minus 1 over x. And let's try substitution. Substitution should be your fallback method. It's what you go to first. So that's going to be the 0 plus 1, the square root of 0 plus 1 minus 1 over 0. 0 plus 1 is 1, the square root of 1 is 1, minus 1 over 0, 0 over 0. Again, we have this indeterminate case that doesn't tell us anything useful at all, and we have to continue going. Now in this case, we're not going to use factoring. There's nothing that appears very simple to factor here. So we're going to multiply by the conjugate of the square root expression. Now remember what the conjugate is. The conjugate means we change the sign of either the square root part, radical part, or the non-radical part. So in this case where we have the square root of x plus 1 minus 1, the simplest thing to do, I think, is to multiply by the square root of x plus 1 plus 1. And we have to do that on top and on bottom. So it's going to be the square root of x plus 1 plus 1, and on the bottom, the square root of x plus 1. Oops, it's gone a little bit too far. Let's see if we can fix this a little bit. X plus 1 plus 1. And note, please, that we changed the sign of the negative 1, now it becomes plus 1, okay? You either change the sign in front of the square root, or you change the sign in front of the non-square root part. Okay? Now, let's try and multiply those out. We're only going to multiply the top line here. We're not going to multiply the bottom line at all, and we'll see why in a minute. So, first of all, if we use FOIL to multiply the expression on top, square root of x plus 1 by the square root of x plus 1, when you multiply a square root by the same square root, you just remove the square root sign, so that's going to be x plus 1. Now then you have the square root of x plus 1 times 1, and the square root of x plus 1 times minus 1. Well, they're just going to cancel out. Okay? So finally, the last thing we have to multiply is negative 1 times positive 1. Negative 1 times positive 1, minus 1 by 1 is minus 1. On the bottom, we're going to write this as x times the square root of x plus 1 plus 1. We're not actually going to try and multiply the x through. We're not going to try and distribute the x. We're just going to write it like that. Okay, let's keep going. This is going to give us the limit as x approaches 0. On the top, x plus 1 minus 1 is just x. On the bottom, we're going to have x times the square root of x plus 1 plus 1. And now I think you can see why we didn't multiply out the x on the bottom. It's because we can see that it's isolated there as a factor, and we can use it to cancel with what's on top. Okay. Now remember, please, that when you cancel everything on a line, it doesn't become 0, you're left instead with 1. So this becomes the limit as x approaches 0. Everything on the top is gone, but we replace it with 1. On the bottom, we have the square root of x plus 1 plus 1. Now we've done our cancelling. After you do your cancelling, that's when, and again I'm having some trouble with the pen here, maybe my batteries are going, that's when we can do our substitution. So this becomes 1 over the square root of 0 plus 1 plus 1, which is 1 over square root of 0 and 1. Square root of 1 is 1, 1 plus 1 is 2. So the limit as x approaches 0 of this function is 1/2. And again, check it out graphically. we want to, our x is getting closer and closer to 0. So if we move closer and closer to 0 on the x, what's happening? The height of the graph. Okay, what's happening the height of the graph? Well, you can see here that the height of the graph is getting closer and closer to 1/2. So again, even though that there is a hole there, even though there is a hole and the graph doesn't have a value there, it doesn't exist there, the limit is still equal to 1/2. So the limit of f of x as x approaches 0 is equal to 1/2. The same as we proved, the same as we showed algebraically. Now, if you have more than one square root expression in your original expression, if there's more than one square root term in the original expression, just conjugate one of them. Okay, you don't need to conjugate both of them, just conjugate one of them, and it will come out without too much difficulty most of the time. Okay, so there's that example. Look back on it as you do some more. Good luck.